Hi. Okay, it's time to start, so I'm gonna start sharing the slides. So today we're gonna try to finish our topic in ATM challenges, and I will be giving you some guidelines for the first homework. So before we start, does anybody of you have any questions regarding last week? Well, last class? No? Okay, perfect. So let's start. So on Monday we saw these two first topics: the challenges in the future of ATM and the single European sky, and we saw a little bit of what CESAR was. So we'll try to finish this today. Maybe I won't have time to see all of it, but if that's the case, I just finished next week. And I will reserve like 10 minutes at the end of the class to talk about the homework one. And also we will be having a little break around 2 or so. So yeah, let's start. So this is what we saw on Monday, a little bit on the growth in air traffic demand, the effect of COVID-19 in this demand forecasts, the growth in diversity in drones and RPAS, also the challenges regarding environmental issues like the emissions and the effects of the climate change in aviation. And then we talk about the single European sky, which is like the ambition of Europe from the future of ATM. We saw what the high-level goals were, the legislative package, and we've finished over here with definition of these functional airspace blocks. And so yeah, we started talking about the project of CESAR, the Single European Sky ATM research. And yeah, we talked about that we are now in the program CESAR 2020. We talked about the three phases where definition, development, and deployment. And we left it in here. So we're going to see today, to finish with CESAR, is, well, not to finish, because the following sessions we're going to be talking about CESAR quite a bit as well. But to finish this section, so we're going to see what is the CESAR vision. What does CESAR wants to accomplish as a project? So CESAR defines his vision as to deliver a resilient and fully scalable ATM system capable of handling growing air traffic, made up of a diverse range of manned and unmanned air vehicles in a safe, secure, and sustainable manner. So basically, they want to integrate all traffic demand coming from a rise in the demand of traditional air traffic, and also the inclusion of these new airspace users. And to do so, they want to do it in a safe way, in a secure way, and also they want to take a look into the environment issues. So this is very ideal. Of course, everybody wants an ATM system that looks like this, but CESAR gives us some solutions and some research and development activities to actually accomplish these visions that they have. So these visions builds primarily on the notion of trajectory-based operations. So the concept of trajectory-based operation is actually quite important in ATM, in the future of ATM. It's basically the ideal for the operational concept of air traffic. Basically, the airspace user will fly their preferred trajectories. This means trajectories that are more efficient, that are less affecting the environment, and they are also most cost efficient. So all airspace users would want to fly their preferred trajectory independent of the airspace configuration, of the air traffic control, etc. So in order to obtain this vision of a perfect ATM system, it is important to build this concept of trajectory-based operations. So in this vision, there's also a new architecture they defined, which is the digital European sky. This is a new concept that they introduced in the past years. So basically, in this architecture, the resources of the ATM, both in the ground and in the air, will be connected and optimized across the network, irrespective of the altitude. That means that the resources will be provided to aircraft flying at very low altitude up to super high altitude operations. And it will also be independent of the class of airspace and the aircraft's performance. So the resources in this digital European sky will be automatically available to all the users in this system. And also, this new digital European sky will have modern technology, which will be used through a data-rich and cyber-secure connected digital ecosystem. So this sounds very, very well, everything, but let's see if when they want to deliver this digital European sky. So this SR Visions tries to improve every stage of the flight. So they try to deliver these 8 improvements, which are first, enabling high network capacity and resilience. So we're gonna go for each one of those and see what they mean by this. So there are 8 improvements. Basically, they will try to improve every stage of the flight. So in this figure over here, we see all the stages in the flight. First, the planning and the pre-departure, when the aircraft has not yet taken off. So in this part of the flight, we will see a benefit using, for example, the optimal use of ANS infrastructure, well, all these different improvements. So we see that for each stage of the flight, we have an improvement that is going to benefit the aircraft trajectories and the aircraft flights in general. So let's go one by one, see what they mean by these improvements, and see what the vision is. So first, they talk about enabling a high network capacity and resilience. So that means that the airspace will be optimized according to flows and no longer according to national boundaries and such. And also, they're going to use cross-sphere cooperation. So this is a step towards this single European sky and this single block. Also, this means that we're going to have progressive levels of higher automation. We will have service-oriented architectures that will enable dynamic and shared management of airspace and remote provision of ATS. So basically, the infrastructures will be able to limit the fragmentation and the rigidness of the airspace. So the airspace will be more flexible and dynamic, and also will be able to the provision of services will be shared across the airspace and will not be based on local architectures. And also, we will see a shift towards flight-centric operations. That means that instead of looking at one flight in a single airspace sector or in a piece of an airspace, we will be looking at the trajectory across a large portion of the airspace. And this will allow us to, of course, increase the efficiency in the provision of air traffic systems and of air traffic services, and to increase the efficiency of the trajectories. So instead of, I repeat, instead of looking at a single sector, for example, we will be looking at a trajectory that goes along a big portion of the airspace. So the second improvement would be to improve flight trajectories. So this is basically based on trajectory-based operations. Anything related to trajectories of base operation will increase the efficiency of the trajectories. So this concept will enable airspace user to operate the preferred trajectory from gate to gate. We will have a communication of the trajectory through a concept which is the system-wide information management communication. So in this concept, which is you will see if you get working with ATM, you will see it a lot. It's basically a communication system between all between all ATM stakeholders. That is a provision of information which is standardized and available to everyone. So if you want to know more about the system-wide information management system, you can watch this video over here. I found it very, very illustrative and very useful. So if you have if you have like 10 minutes, just please give it a look, because I don't think, yeah, I think it's a very nice concept to know about, and it's also a very important in the future of ATM if you want to deliver this vision. So yeah, basically this TVO will mean increased predictability and fuel efficiency. The third improvement would be airport performance and access. So basically better airports in general. We will have new approach procedures, the use of remote tower services that right now we are using at airports with low traffic, but the objective is that it will be extended to medium traffic airports as well. Also a better performance in the airports that will be possible to big data analytics and artificial intelligence, and improvements in the safety, using support tools and alert system for air traffic controllers, and also onboard enhanced vision system for pilots accessing these airports. An additional improvement would be enable greater airborne automation, and this is particularly important for the integration of drones in the U space. And this increasing in airborne air automation will allow greater levels of autonomy and connectivity, and also will allow different different kind of operations, like for example single pilot operations. So I'm sure you know this, but commercial flights have two pilots, a pilot and a co-pilot. And so being able to fly a commercial plane with one single pilot would mean that you will have to have a completely autonomous a virtual co-pilot, so to say, so the operation does not decrease in its level of safety. And also the next step in single pilot operations will be to have a fully autonomous flight. Personally, I think that is too far away for commercial flights, but for smaller flights, like in general aviation, for example, I don't think it's too weird of a possibility, but well, let's see. So yeah. And finally, another benefit of increasing the automation will be the integration of both manned and unmanned air vehicles. Next, we have the improvement of ANS productivity. So basically, this productivity of our navigation services will improve thanks to first increased levels in automation support for air traffic controllers. So air traffic controllers will perform fewer manual tasks, and also this will decrease their workload, so they will be more efficient. We will move from voice to data communication, and also we will have better connectivity and information sharing between ground systems. And this is very important if we want to meet the growing demand. The other improvement would be the unoptimal use of ANS infrastructure, for example, through standardization and virtualization of the services. So this is also related to the use of remote centers for air traffic control in TMAs and en route, and the use of remote towers in airports. So these two concepts will allow the ANS to be more flexible and, of course, more efficient. Then we have increased global interoperability and collaboration. So again, through SWIM, we will have a better collaborative decision making, and we will have standards for the information exchange so that all the stakeholders in the ATM system can communicate efficiently and make decisions together. And this also a nice addition in this improvement would be the big data management. So through the ATM system delivers a lot of data from single flights, for air traffic services, for ANSPs, and using all of this data to be able to give us a better information and to help stakeholders to do better schedules and do a better planning processing would also be a concept in the future of ATM that I think this particular thing we have not so far away, because we are seeing that right now that big data management and data analytics is a big topic in general in our society nowadays, especially for internet related things. So a lot of advantages have been done, and I don't think this is too far for being implemented to ATM system. Actually, Aerocontrol has a lot of projects related to big data management and such, especially for trajectory prediction and that kind of thing. And last, we have enhanced safety and security. So all of this task will have to be done meeting safety standards, because safety is the most important thing in aviation, basically. So these improvements in automation will support higher levels of safety. Also, more safety nets will be enhanced in both airports and airborne flights. And finally, we will have a better collaborative process between civil and military stakeholders. So this is what Cesar wants in general about the future of ATM, how they envision this European ATM system to be. Of course, it's very ambitious. This is not something that we're gonna achieve in 5 years or so. It's something that it will take a lot of, it will take some decades, but all the steps are going towards this direction. And of course, this vision is of today. 10 years ago or 5 years ago, people were not even thinking about drones because they were not such a, they didn't know that there were going to be so many business opportunities for drones and air cars in the ATM. So with the coming years, we will have new technologies and new business opportunities that we will have to integrate in this vision. So that's why the European ATM master plan is constantly updating, because they want to take into account all these new developments. So if you look at the European ATM master plan for 2009, the vision and the performance ambitions were so very different as they are of today. I mean, the concept in general is the same. They want a better efficiency, more capacity, blah, blah, blah. But yeah, these all new technologies, this emphasis on digitalization, that's kind of new. So this, yeah, expect that this will change in the future. So this is not like the final, this is not exactly what the future of ATM could be, but as of today, that this is the best that we can aspire to. Okay, so let's talk about the CESAR phases. So in order to deliver this vision, CESAR has proposed four phases, which are phase A, phase B, phase C, and phase D. So these are four phases. We reflect the steps towards this digital European sky. So in the phase A, we will address non-critical network performance deficiency. So what are the problems of today? In phase B, we have efficient services and infrastructure delivery. So we start implementing those research and development solutions. Then in phase C, they envision that we will have a defragmentation of European sky through virtualization. So at this point in the future, the airspace in Europe will no longer be fragmented, and we will have different remote centers and virtual centers to provide air navigation services to the whole system. And finally, the phase D is the target vision, is the future in the long term. So this is the whole vision of the digital European sky. So basically, through going through these phases, the system will move from a country-specific architecture to an interoperable, global, and flexible provision of service provision infrastructure. So we're going through a country-based ATM to a global ATM. So these phases overlap, and the first three ones are already being deployed or in the pipeline towards deployment. So this is not something that is something in the future, like a vague promise. It's something that in Europe, some projects are already working on. So let's see these different phases, what they mean. So in phase A, we have to address non-critical network performance and efficiency. So right now, this is where we are today in phase A. More or less over here. So in between phase A and phase B. So in phase A, most air navigation service providers are vertically integrated into a country-based infrastructure that we have today. ANSP belong to a given country. So yeah, in this figure over here, we see the countries represented as vertical columns. So we can see that the services are either in one country or other country, but never shared. The network manager operates over all these countries, and the airports belong, of course, to either one of, they belong to these countries are separated, they are not integrated in the network. But there's some kind of interaction between ATC, like for all the cross-operational activities and such. But what we see in this phase is an initial adoption of a service-oriented architecture. So we are taking these initial steps to see this service-oriented architecture, because traditionally we have a technology-oriented architecture. This means that we have this technology, we have these services, and you have to work with that. So that's kind of what we have today. We have several infrastructure that do certain things, and flights work with that infrastructure. But what we want to do, what we want to achieve in the future is to say, okay, I want this service, and somehow somebody will provide it to you. A navigation service provider or a communications navigation and surveillance installation. But in general, we go from I have this technology and I will use it the best I can to I want to do this and I need this service to do this. So the air navigation service providers will be able to provide those services based on the performance and based on the necessity of the ATM stakeholders. So in this phase, we also see the implementation of SWIM. Again, please give it a look at that video. It's very informative, but I repeat, SWIM is like a communication sharing system, which is standardized and where the information is available to everyone. And this is quite important because traditionally, an air navigation service provider we have, or a country will have a technology and will have communications that are local. So being able to have a standards to everybody in the ATM community allows that interoperability between players. And this interoperability it's what makes the global airspace more efficient. And this phase has already started, and we have some development solutions that has already been delivered. Then we have phase B. So also in this year over here, we do see that the performance increases as we go up in the phases, but that's something that you already catch up on, I guess. So in phase B, we have efficient services and infrastructure delivery. So in this phase, we will have a common service layers achievable through access of airspace data service providers. So you can see in here that the services and infrastructure are no longer tied to countries, but are shared between them. That's something important to have a more efficient service and more efficient infrastructure, and not being constricted by local boundaries and local regulations, but being able to provide those services to a whole through spheres and through countries. We see more cooperation between ATC operation, and again we start to see how airports are more connected between each other through information sharing, and also connected with the network management, with the network manager. So we will have the move from physical infrastructure to virtual infrastructure, and increasing automation. We will enable remote provision of ATS. Again, this one important thing to have services across different countries is practically this virtualization, because if we are considering local architectures that are analogic, as to say, like for example, a beacon that has a given range, of course that cannot possibly go through boundaries and through countries because it physically cannot reach more than its capacity. But if we have a virtual data center, or a virtual or a airspace digital service provider, we will have these services available in every place that we go in the airspace. So that's one change that will be important to deliver this phase. Also in phase B, we will start to see more airspace users like drone operations, very high altitude operators, and use-based service providers. Then we have phase C, which is titled the fragmentation of the European sky through virtualization. So in here we'll have automation, greater levels of automation and connectivity. The flight will be managed and optimized as a whole. We will have an integration between ATC and ATF-CM, which is quite important, I think. So in here, we can see that the lines between the different countries are a little blurry. So that means that the ATC is not tied to those national boundaries in the countries. So ANSPs in the respective national borders will be able to plug in their services when they are needed, providing end-to-end services, sharing resources among ANSPs. And also in this phase, we will have drone operations that will be routing operations, even if they are not fully integrated into the ATM. And finally, phase D would be the ideal vision. The ATM and aviation will evolve into an integrated digital ecosystem characterized by distributed data services, a fully scalable system, and the delivery of this digital European sky has been set a date to 2040, and it's very ambitious. And this will, if we want to implement this digital European sky as of that date, it will require changes to the regulatory framework and shorten innovation cycles and time to market. I don't know what you think, if this will be possible in 20 years. For me, it's very ambitious, but some people may not be that pessimistic. But yeah, let's see what the future brings. So this is basically what I told you already, a little summary of the different phases. We see how the levels of automation increase through the phases. And this is a picture of the different levels of automations and how the different phases of Cesar will work with his automation. So I don't know if you are familiar with the scale of automation, but it goes from 0 to 5, depending on whether the human does most of the task, to the automation, there's no human operator. So basically, with each step, we are giving the human is doing less and less task until we have a fully automated system. So we see that in phase A, we will have very little automation. In phase B, we have to differentiate between air traffic control and use-based services, because of course use-based services will have higher levels of automation. So we see that B and C, we have levels 1 or 2 of automation. So up to level 2, the action is only initiated by human. So this is what we have in phases B and C, and we see that we are very how is the word? We are not very happy with giving automation to higher levels for ATC, because we don't trust automation that much. I would say, and also because having a human do the task is right now is more safe than giving up to a machine, because of course the technology is not yet there for meeting those levels of safety. But in phase D, we will have more levels on automation, but never reaching the level 5, which is no human operator. So even in the most futuristic state of ATM that Cesar can envision, that there will not be a fully automated ATC service. But that's not the case with U services. So U services, we will have very high levels of automation, all where our actions can be initiated completely without the intervention of humans, and up to no intervention at all in the last phase. So yeah, after this class, let's give it a look at this summary over here. I think this is not only this. So this scale is not only applicable to aviation. It's applicable to any kind of operation that you may think that will require automation. So it's quite nice to read. Okay, so we have seen the single European sky. We have seen what the vision is and what the phases to deliver this mission are. So now we are going to take a look to the performance ambitions. So does anybody have any questions? Okay, I know it's a lot, but I mean, ATM is a lot. Okay, so let's go with the performance ambitions of Cesar. So in 2009, with a target date of 2020, so last year, these were the ambitions of Cesar. They wanted to have a 23% increase in capacity in comparison with 2004. With the accidents and risk will not increase despite air traffic growth. They will also want to have a 10% reduction per flight in environmental impact compared to 2005, and a 50% reduction, of course, per flight compared to 2004. So these ambitions were not met by last year, but they have been revisited since then. So with each edition of the European Master Plan, new ambitions were set, taking into account new air traffic demand data and new technologies. So the ambitions that they have right now have a target of 2035, and they are comparing it to data from 2012. The performance ambitions are categorized in 6 KPIs, in 6 key performance areas. So you remember that last week we talked about ICAO key performance areas. We have a list of 11 of them. Cesar has its own key performance areas, but they are included, I think, in the ICAO ones, and they have capacity, cost efficiency, operational efficiency, environment, safety, and security. Let's go a little bit over one of them. So capacity, basically, they want to tackle the capacity crunch and address the risk of unaccommodated traffic and increase the good traffic throughput. Basically, they want to accommodate the demand. In the cost efficiency, the ambition is to provide technical system changes that reduce the cost of the services. In general, so they want to enhance the overall productivity of ANS provisions. So each flight costs less, both because of the operations in the flights and both because of the provision of air navigation systems. Then we have operational efficiency, which is a decrease in the price in the cost of a single flight through the reduction and better management of departure delays and efficient flight plans. And this will reduce the fuel consumption as well and increase the predictability. Then we have the environment, where the ambition is to achieve a reduction in the gate-to-gate CO2 emissions. And these two over here are very related, because if we have a better operational efficiency, we will have better, less emissions due to inefficiencies in the operations. Then we have safety. So the ambition is to have 0 accidents as a consequence of ATM and ANS. And finally, the security, which means that the ATM should be protected against security threats. So these are the performance ambitions of CESAR. They are, as I said, classified in these 6 key performance areas. In here, we see the CESAR, the Single European Sky, high-level goals. These goals were set in 2005, with the when first the CESAR, the Single European Sky was envisioned. It was to increase the capacity for 3, reduce the cost of ATM services by half, enable a 10% reduction in the effects of flights over the environment, and improve the safety by a factor of 10. So this is what the ideal of CES was defined in 2005. And this is the key performance indicators that CESAR has used to measure these key performance areas. So for example, let's go through the capacity. So they measure the capacity with one key performance indicator, which is the departure delay. So this is the average value. So the baseline value in 2012 was 9.5 minutes, and they want to decrease this value in 2035 to a number between 6.5 and 8.5 minutes. So this would mean an absolute improvement on 10 minutes and a relative improvement on 10 to 30%. So they have all these ambitions. Of course, they want to increase the number of AFR movements, which means a 5 to 10% increase in these AFR movements. The flights through the network, or the in-flight hours through the network in here as well. We can see that these numbers increase a lot. In case of cost efficiency, it is measured with the key performance indicator of gate-to-gate direct ANS cost per flight, or how much does the ANS service cost per flight. So they try to drop it from 960 to around 600 with a relative improvement of 40%, 30 to 40%. The operational efficiency, they want to decrease the gate-to-gate fuel burn per flight at 5 to 10%. And we can see how this is directly related to the reduction in gate-to-gate CO2 emissions, because they are the same values. They want to reduce both the fuel used and the emissions from 5 to 5%. And yeah, they want to completely eliminate ATM-related accidents, and they want to achieve a security level where there are no significant disruption due to cybersecurity vulnerabilities. So these are the ambitions for 2035. We will see by then if they have been met. But yeah, this is what the solutions are there for. So in the I must say that these performance ambitions has been computed by CESAR using a data-based approach. Are not just numbers thrown and say, okay, this would be nice. This number has actually been computed using the forecast for traffic demand, the forecast for the provision of different solutions and technologies. So basically, if everything we see in the ATM master plan goes according to plan, we will be able to achieve these performance ambitions. Okay. Okay, so perfect. We're gonna have a little break here. So I will give you 10 minutes and we will continue with the single European airspace system. So do you have any questions?
I have a question.
Okay,
So can you go to the back one slide, maybe?
this one?
Uh, yes. Isn't it could to like reduce emissions from air traffic with 10% in 2035 compared to 24? Isn't there a potential to reduce the emissions more, if you understand what I mean, more than 10%?
So you are asking if it would be possible to reduce it even further?
No, if you look at the environment, the environment, like there in the it says enable 10% reduction in the effects slides have on the environment. Could why isn't there any goal more than 10%? Because 10% sounds very small, if you understand what I mean.
Yeah.
It was from compared to 2004 as well.
Yes.
So
I see. So this is my opinion. I'm not. I don't know what they were. What was the process of thought when delivering these limits, but you have to take into account that they want air traffic to increase and increase over the years. So it will be very naive to think that we can decrease the environment footprint even further while also accommodating a lot of flights. And you have to think that this is ATM. So we are not considering the inclusion of different fuels or electric aircraft. So that's not what the ATM is working with. So just with ATM operations and ATM technologies, I don't think it is possible to reduce it even further if we want to accommodate so many flights. So I think a 10% reduction is of itself very ambitious as it is, and trying to reduce it even further, I think is not in accordance to this goal of having more and more capacity and demand. I don't know if
okay.
this is my opinion. I'm sure other people all think differently. But
I thought it was per flight, but okay, it maybe was as a whole.
no, I forgot. This ambition is per flight, and this is the and so you were asking about this one or about this one?
Yes, this one on the left.
Yeah, so these are the ambitions that were set in 2005. So yeah, I'm not sure if that is per flight or not. Oh yeah, it's totally per flight. Yeah, okay. But either way, I mean, either way, there's no so much leave room over there if you want to maintain the levels of safety and the levels of capacity to achieve those perfect trajectories. So I think this is quite high in my opinion. So this is a balance between having the reduction in the environment and a balance between having a lot of accommodation of demand. So we will have to see if there is any ambitions by any other projects around the world or any organization to decrease this footprint even further. But as of today, as regarding the European Union and regarding CESAR, these are these are the performance ambition.
Okay, thanks.
No problem. I'm sorry about the confusion of the per flight and everything. Okay. Okay, so let's have a break until 2:15, okay?
Okay.
Okay, see you in a minute. Hello. Okay, I don't know if we should start already. Okay, I see a thumbs up. Okay, we'll start. Okay, so let's continue. We have seen the performance, and now we are going to see something which is the single European airspace system, which is the future of the airspace in Europe. So this single European airspace system is based on something that was developed by CESAR joint undertaking, which is this over here, a proposal for the future architecture of the European airspace. It was developed by CESAR joint undertaking with the support of Eurocontrol, and it was delivered to the European Commission in February of 2019. So this proposal aims to address the airspace capacity challenge, combining airspace configuration and design and technologies to decouple the service provision from local infrastructure. So this is a proposal for how CESAR wants the future of the airspace system to be in Europe. So this is the current architecture. We have a physical layer where we have different countries that are separated and have infrastructure that are fragmented. We have an air traffic service layer which has a vertical integration of application and information. So what we have in a country, the air traffic services will have information about that, and the airspace flying over that country, over that airspace, will have air traffic services delivered in a vertical way. We have low levels of information sharing, limited automation, and in general, we have limited capacity, poor scalability, etc. So this current architecture is the result of historical, operational, and technical evolution conducted at a national level. This has led to the airspace to be fragmented, which we know now this is not efficient. So in this fragmented system, each area control center is a node in a global network, which some of them are already operating very close to maximum capacity. Resources, including data and their ability to deliver service, are not connected across the network, across those nodes. So the services that and the data that one area control center has is not shared between area control centers. So this means that if one node has a problem, this problem will spread across the network. And when an airspace user encounter delays, these newly formed delays from one flight can easily propagate to a second flight and a third flight. And these kind of delays that are going to propagate through the network can be absorbed by buffers, but not all of them. And also the existence of buffers in the schedule is necessary. So this is a very fragmented structure, which is not efficient. And this is what we currently have nowadays. So in the current architecture, we have some factors that are limiting the overall capacity. For example, a non-optimal organization of airspace. Airspace is not organized depending on flow or depending on operational necessities. It is organized mostly because of national borders. We have a limited use of data communications, limited opportunity to create new sectors, and limited automation support for controllers. So this is limiting capacity, and there are some factors that are limiting scalability and resilience. Just to remember, scalability is the ability of the airspace to accommodate more and more flights. So in order to accommodate the increase in demand, and the resilience of the capacity is the ability of recover from a disturbance. So for example, those delays that propagate means that there is very little resilience. In a system with a lot of resilience, if one delay takes place because of a given disruption, the system will recover very quickly, and these delays will not propagate as much. So the factors that are limiting the capacity, scalability, and resistance are that we have limited predictability, again, limited information sharing, limited flexibility in the use of controller resources across different area control centers. So one single controller is responsible for sectors, but it cannot operate in different sectors. And also, of course, the hierarchical constraints on ATS provision. So what are we going forwards in the future? So this is the future architecture that they envision. We have the infrastructure, which is shared between the states. Of course, it has a given location, but the infrastructure is integrated and rationalized in the ATM structure. And also, in comparison with the other one, we saw that we have a vertical integration. So each one of these services gives a service to a given air traffic service provider. So the infrastructure is connected vertically. In here, we have a shared information that goes to data centers. And from these data centers, the resources and the data is provided to air traffic services and also to EU space operations. So we no longer have this vertical dependency, but we have an infrastructure that is giving information to the whole airspace. We have higher levels of automation support and virtualization, which means that we have scalable capacity. And then we have the airspace, which is no longer, again, vertical, but we have services that are provided along the whole airspace and not limited to the state's boundaries. So for example, this gray line over here represents the borders between state A and state B, but we can see that the ACC sectors go through these national borders. And also we have new players, which are, for example, higher airspace operations, of the use of airpass and drones flying alongside traditional air traffic, and also the presence of drones in the lower airspace. So this is the future architecture that they propose. In this future architecture, we have the notion of single European airspace system, SEAS. The resources are connected and optimized across the network, which has modern technology with flat data rich and cybersecure connected ecosystem. In contrast to having airspace as a provision according to national borders, we have this service provision has been optimized according to traffic patterns. And this new airspace system will accommodate new forms of traffic. So these are the solutions that will allow the implementation of this future architecture. For the solutions that will improve the capacity overall, we have an optimized airspace organization, operational harmonization, and automation and productivity tools. And the solutions that will allow increase in scalability and resilience are the virtualization and ATM data as services. So we transition from location-based centers to virtual centers and common data layers. So we no longer have that vertical association between infrastructure and air traffic services. Then we have the dynamic management of airspace. So the airspace will be managed according to the necessities of the airspace users through dynamic grouping and the grouping of sectors. We will have flight-centric operations. So this changes the responsibility of one controller, which traditionally one controller is in charge of a single sector. So now, through these flight-centric operations, one controller will be responsible for the whole flight of the aircraft across a bigger section of the airspace. And also, one important thing would be that ATS operations could be sector independent. This means that right now, air traffic controllers are trained and are certified for a given sector, and they cannot provide their services to another sector because they are not prepared for that. They don't have the expertise to that. But shifting to a performance-based system, ATCs would be able to provide their services across multiple sectors. So the configuration of the sector will not be no longer important, but the performance of the operations within that sector, every air traffic controller would be able to provide their service across multiple sectors. And finally, we have enhancements in communication, navigation, and surveillance systems. So they envision a transition strategy with increments of 5 years. So at the end of 2025, these milestones should be achieved, like the implementation of free route, air ground and ground connectivity, different solutions that they envision. In 2030, so in 10 years, we will see these solutions implemented, like, for example, capacity on demand or higher levels on automation in support by SESAR solutions, implement of virtual centers. And finally, the vision should be fully implemented in 15 years. With the transformation to flight and flow-centric operation, trajectory-based operation, and service-oriented and traffic management. So yeah, they envision that by 2035, they will have this single European airspace system delivered. Okay, so let's continue with SESAR essential operational changes. So what is an essential operational change? An essential operational change is a game changer that is triggering a structural evolution in the European ATM. They are required to deliver SESAR vision. Basically, they are big changes that are going to take place in ATM to deliver this future digital European sky. They are not independent from each other, and they are the following. They have considered 9, but through the different editions of the ATM master plan, they identified different essential operational changes. So these are the ones for the edition of 2020. So they have changes in communication, navigation, and surveillance infrastructure and services, US-based services, a fully dynamic and optimized airspace, an interconnected network, the virtualization of service provision, trajectory-based operations, digital, the A is for aeronautic information management and meteorological systems services, the improvement of airport and TMA performance, and something that they call multimodal mobility and integration of all space users. First, before we go through every one of them, we're going to talk about SESAR solutions. So what are SESAR solutions? SESAR solutions are new or improved operational procedures or technologies that are designed to meet the essential operational changes. So they are self-standing packages that aim to contribute to the modernization and high performance on the European ATM. These solutions usually take the form of a project that is carried out by an organization, a university, a company, and they are collected in this CESAR solution catalog. So in this catalog are all the solutions that either have been implemented or are being implemented, or they are ongoing projects. So these are these little pieces that will eventually construct the future European ATM. These CESAR solutions are grouped into 4 key features, which are optimized ATM network services, advanced air traffic systems, high-performing airport operations, and enabling aviation infrastructure. So let's see a little bit what they mean by these 4 key features. So in high-performing airport operation, this includes airport management, remote towers, run with throughput capabilities, etc. Everything that's improving the operation of airports. Then we have advanced air traffic services. This includes time-based separation, a better sequencing of traffic, automation support tools. Then we have optimized network operations. This includes dynamic collaborative tool to manage ATF aircraft configuration, civil and military collaboration, everything related to air traffic flow management. And then we have enabling infrastructure, which are in this we include, for example, this communication, navigation, and surveillance integration to facilitate economies of scale. And one important thing is the presence of SWIM, the System-Wide Information Management Government, the education and technology solutions, etc. So all related to infrastructure and data. So let's go back to the essential operational changes. They are this 9 over here. Let's go through them. So then we have CNS infrastructure and services. So historically, we have national ownership of the infrastructure. This also they have the need to support a variety of heterogeneously equipped airspace users. So each aircraft will not have the same avionics or the same communications procedures. So this is an efficient distribution in general of the equipment. Ideally, we will have an infrastructure and airspace users that will use the same communication procedures and the same information. So the main challenge is to optimize the infrastructure and use it efficiently, both in the ground and in the air. And these changes will be driven by a service-based approach and a performance-based approach, as opposed to a technology-based approach. So we talked about this earlier today, but the shift would be from a technology-based approach where the technology is given and we want to make the most of it, to a system when you define your performance, you define your ambitions, and the infrastructure will be enough to give you the services that you need. This means that they're going to be service-based. In this approach, the communication, navigation, and surveillance services provider and air navigation services provider may be different entities. So as of today, normally air navigation service providers are responsible for implementing the infrastructure and maintaining them. So in this future system, the air navigation service provider will be consumers of the CNS services. Then this also will allow the decoupling of CNS services from air traffic services and air traffic management data services. And in general, this will make the system more flexible, resilient, etc. Then we have the ATM interconnected network. So traditionally and as of today, we have a wide variety of applications developed over time for specific purposes. And these interfaces between these applications are custom designed. So they are managed locally. This means that they are not constructed to function as an element of a network. We have this solution, we have this technology, and you just have to make the use of it. So there is a strong case for standardization in of the ATM system interfaces. So what the essential operational change could be to have a ATM collaborative network, which will allow all the users, all the stakeholders to participate in a collaborative decision making process in a network that is transparent, and they will negotiate their preference and reach agreements. And this interconnected network will allow to have a real-time visualization of the evolving network. And also one important part of this essential operational change is the integration of air traffic flow and capacity management and air traffic control planning functions. This means that the operations of the network and the operation of air traffic services will be a lot of interrelated, because the function, the network as a whole will be managed in a collaborative process. So the lines that differentiate ATC and air traffic flow and capacity management will blur a little bit. So we will have, ideally, we will not have an ATM system that is segregated. I mean, we won't have that branch structure that we saw last week. We will have a whole provision of services. Then we have digital aeronautic information management and meteorological services. Basically, they want the information to be available and shared at all times, also through digitalization. Then we have US-based services. This is basically the need for integrating drone traffic management system and different aerospace users, and enable simultaneous drone operations. So basically, in the end, US-based services will rely on high levels of digitalization and automation, and all these new airspace users will be integrated into the air traffic management system in a safe way, in an efficient way, etc. So the use space is the framework that is enabling the inclusion of these new airspace users in the ATM network. Then we have the virtualization of service provisions. We talk a lot about this. I think we talk about this in the airspace when we talk about the airspace, but we will see it again as an essential operational change. So traditionally, the provision of air navigation services is based on local implementation of the necessary capabilities, and this is this results in a fragmented situation. So by using digitalization, the physical processing capabilities will no longer need to be close to the point of use. So an airspace user that is flying kilometers away from an infrastructure, through virtualization, will be able to access the services and data from that infrastructure. And this will, of course, provide the ability of performing air traffic services from a remote location. In these essential operational changes, we have the remote tower concept in the airports, and also in outside airports in the terminal maneuvering area or route. We have something that's called virtual centers. So this will be the equivalent in the airports, but for the ACC. So these virtual centers will allow the geographical sector to be managed from any place. So instead of having an ACC in a given geographical location, the services provided by an ACC will be could be provided anywhere, independent of the location of that sector. So this is, as you know, this has already been implemented in some places. This is a little further in the future, but in general, the more the services and the more the data is being virtualized, the closer we are to this remote provision of services. Then we have airport and terminal maneuvering area performance. So nowadays, airport operations and airspace users operation are significant contributor to delays due to capacity issues and weather conditions. So this essential operational change covers changes to airports and terminal maneuvering area that allow the maintenance of the operational capacity under limiting conditions. This means that under distress or under giving events that are disrupting the operational capacity should be maintained, and also covers changes that allow an increase in the operational capacity. This includes improvement in the planning and execution of operation, both in airports and around airports. We have then fully dynamic and optimized airspace. This is basically what we talked about in the previous section, the implementation of a future airspace that will be fully flexible, a step towards trajectory-based operation and free routes. And one thing that I think it's a nice concept is what I mentioned earlier, but the main change is to move from airspace management collaborative process into a fully integrated airspace management, air traffic control, and air traffic flow and capacity management through a collaborative decision-making layer process. So in the end, they want these three big ATM services to be fully integrated in order to give a better service in the end. Then we have the concept of trajectory-based operation that we talk about this when we saw the vision of CESAR. Trajectory-based operation will enable airspace users to fly their preferred trajectory. In contrast, what we have today, which is that the national provider is maintaining its own partial data on the flight. So in the concept of trajectory-based operations, a trajectory will be created and agreed for its flight, representing the business needs of the airspace user. And these reference trajectories that the airspace user agreed to fly, the air navigation service providers and the airports will agree to facilitate this trajectory. So the users will be able to fly the preferred trajectories, which will, of course, deliver more efficient and a more cost-efficient flight as well. And lastly, we have the multimodal mobility and integration of all airspace users. This one is a little bit weird. This is not something that you would normally think of when you think of ATM. But it means that with this concept and this change, they want to integrate different modes of transportation to deliver a door-to-door service. So the passengers will not need to worry about selecting the most appropriate means of traveling, and various modes of transport like car, train, helicopter, example, will be seamlessly combined. So in the future, we will, when we think of travel, we will think I'm going to point A and point B, and all the services that we encounter on the way will be perfectly synchronized and everything will be great. So what this means regarding air traffic management is that air traffic management must be flexible enough to accommodate these new developments. And that's it for the essential operational changes. And let's continue with the deployment of SSR solutions. So SSR solutions fall within 3 categories. First, we have solutions that are delivered. This SSR solution has been successfully rolled out from research and development and has demonstrated benefits, so they are transferred to deployment. These are mature solutions. These solutions are included in phases E and B of SSR. Then we have solutions that are in development, so they are under development and are expected to reach readiness for industrialization within the life of SSR 2020. These are solutions that will be developed during phase B and phase C. And then we have the last category, which will be estimated future research and development, which are solutions that are needed to achieve the digital European sky, that are needed for phase D, but they are currently being further explored. They are not as mature as the other ones. If you follow this link over here, you will see a list of SSR solutions and what is the state of development. So please, if you want to give it a look, that could be, it's a very nice web page. And also you can see that it's not only an idea, it's not only good intentions, they are already in deployment, and that solutions bring benefit to the ATM. So in the status of the solutions, we see that the delivered in the whole catalog of SSR solutions, around more than 1/3 have already been delivered. I'm sorry. A little less than 1/3 are in development. 32% are estimated future research and development. And of this 37% that has been delivered, 70% are with deployment decision. This means that a decision has been made in order to deploy this, and they are part of the European Master Plan Level 3. So this the Master Plan has different levels. The first one is the executive level. The second one, I think it's the BIS. I don't remember the name of the second level. And the third level is the deployment level. So in here, they have the deployment plan for SSR solutions. And as I said, 70% of those delivered solutions have a deployment decision, but 30% of them don't. And of those 70%, 48% are regulated, which means are part of the pilot common project, which we will talk in a minute, and 52% are not part of this project. So what is the pilot common project? So this was a pilot initiative to deploy SESAR solutions in a coordinated and synchronized manner. It was part of a European legislation, which is this one, in 2014. And the target dates to deliver these solutions were between 2021 and 2025. And we see that 71.8 of the solutions inside PCP has been delivered. And now we have another legislation that, so this is finishing very soon. So the new legislation with a target of 2027 is the Common Project 1. And well, these two common projects and the regulations are basically, they want to provide funding to these solutions and these projects to deliver SESAR solutions. So these are the milestones of the development of SESAR as they envision in their master plan. So we have phases A, B, C, and D. So let's start with A. Phase A should end in 2025. So these little symbols mean the start of deployment. The yellow triangle. The rhombus means full operational capability. And the blue triangle is research and development readiness. So the phase A started years ago and has we will finish. It will be finished by 2025. That is in 4 years. Phase B should be finished by 2030, around in 10 years. Phase C should be finished by 2035. Remember that this date was the same as the development, as the development of the airspace new architecture. So by 2035, we should have the defragmentation of the European skies. And then we have phase D, which they envision 2 options. One, all the research and development and all the solution of SESAR are done efficiently and fast. So this means that the phase D will be achieved by 2040, so in 30 years. But if that's not the case, and they have some difficulties implementing the solutions and the scenarios, we will have a phase D that will be achieved in 2050 or later. And of course, the EU space deployment will be a gradual over the following years. Then for the drone operation, the deployment vision is the following. For remote pilot aircraft, we will have that for in airspace of classes A and C. So you remember the classification of airspaces, right? From A being the more controlled to G being the less controlled. So we will have phases Airpass 1, 2, and 3. The first one should have been already implemented when I think that it has. And the last phase, which is the integration of Airpass with instrumental and visual flight rules, will be developed in 2030. And for the EU space, we have 4 phases, starting the foundational service that was a couple of years ago, to full services in 2035. And last, I want to give you an example of what a timeline for SESAR look like. So if you go to the European Master Plan webpage, you will see things like this. You have the essential operational change and a given solution for that essential operational phase. And these lines over here means the blue squares means that the solution is in deployment. So this would be, for example, this one, integrated service management. This one started last year in 2020 and will finish in 2027. and the light blue means that this solution is providing benefits to ATM. So this one is started in 2020, and it's expected that will bring benefits as soon as 2022. So all the solutions in CESAR, well, not all of them, those that are not mature enough, do not have this kind of implementation plan. But solutions that are mature and that are in the lines towards deployment, have this kind of schedules. And this is an example for mature solutions, and these are examples for solutions that are approaching maturity. For example, something that we talked earlier, the virtual center concept, which was the equivalent of the remote towers, but for en route services. This project will start this deployment in 2022, and it's expected to finish in 2032, and is expected to start giving benefits in 2024, and that in 2032 they will have achieved the full concept, and all the benefits are available for ATM. So this is what the deployment of different solutions look like, and that's it. That's all for this subject. And here you have the bibliography I've been using, and again some online resources. And now I want to talk to you about the homework one. But first, I would like to hear if your thoughts about this. Do you think that this is our vision and the deployment milestones will be achievable or not? So what do you think?
Well, it's a hard question.
Yeah, I want to know what your opinions are after hearing all of this.
I mean, yes, it's probably achievable, but they will have to work like really hard to make it happen, I think. But yeah, I don't know. We will see, I guess.
Yes. Okay, so personally, I think that it's very ambitious, especially because they are devising all this ideal and utopic ATM. I mean, of course, we will have improvements, but I think it's very ambitious. I think this line will be, I don't know, over here. I don't know. Let's see what the future brings. So now I'm going to talk to you about the first homework. This will be very quick because it's 3 already, so I'll go through it in 2 minutes or so. For the guidelines, the topic. The homework one will be to choose a ATM topic and write a little essay about it. And also you will have to find and write about scientific papers or projects about the topic that you choose. The essay will be 1 page or 2 pages long, so nothing too long. Of course, you can write more if you feel like it. And it is okay to copy and paste things, but make sure to cite everything that you use, every reference, and I mean it's always okay to. I mean, not always if you are doing a work that is yours and not only essay for a course. But in this case, you can copy and paste, but you always have to say where did you obtain this information from and all of that. And the objectives of the homework would be that you have to research and read about an ATM challenge and solution. You have to understand the roles that it has in ATM. So what are the challenges? What are the benefits that the solution brings, etc. And I want you to get a piece of the picture of the research and development in European ATM. So if you have to choose a topic, you have to read about it. You have to find some scientific papers or projects that are about the topic. Maybe they will not be exactly about that, but related to that topic. And you have to write a little essay. So what is the list of ATM topics? So the list is CESAR solutions. This is the list that I'm giving you, and you can choose one of those CESAR solutions and talk about them. So you have to choose one of the solutions that are listed in the European ATM Master Plan. First, choose one essential operational change that we saw today. In the master plan, they are between pages 33 and 79. Read about that essential operational change and choose one of the solutions related to it. In the master plan, you have in these pages a list like this, when you have an essential operational change and a list of solutions. And also you will have the solution code. So using this code, it will be very easy for you to find information about the solution and about the topic. So yeah, you choose one CESAR solution, and this will be your ATM topic, okay? Alternatively, you can choose any topic you are interested in about ATM. Just write to me, send me an email, and say, okay, I don't want to talk about this CESAR solution. I want to talk about, I don't know, capacity in general, or I want to talk about why the ambitions for environment were so low, or I don't know, whatever. Just write to me, and I will say, okay, this is too difficult, or this is okay. So you don't have to be limited to this list, but this list will make things easier for you. Just choose one and write about that solution. So the bibliography would be the European ATM Master Plan, which is this one. In these links, you can find both the document and the portal. The portal is very useful. It has a lot of information. It has the same information as the document, but it's structured in a nice way. Also, you can use this CESAR solution catalog, which is this one. This is a link for the catalog, and this is our webpage. And so what should the essay contain? So you must write about the context and objectives of the solution. So what problem or what ATM challenge does this solution tries to solve? Is this focus on capacity? Is focus on safety? What is the general context of the essential operational chain, etc.? What are the benefits of the solution? So just write a nice essay stating what you may think is necessary. So one important part of the homework, apart from writing a little bit about the topic, you have to find scientific papers. It can be obtained from peer-reviewed publications, can be conference papers, it can be deliverables for projects, and you must find this scientific paper project about a topic or related to it. So even though you not find one scientific paper for this particular solution that you selected, you can, if you find some scientific paper that is more or less related to it, that would be fine. So first, you don't have to read the whole paper, and you don't have to comprehend the whole paper. This is a difficult task to do a literature review. Just find some papers or some projects that are related to it. Read the abstract, read the introduction, and yes, just find some bibliography. In general, this would be like the first step that you take when you make a bigger project. So you choose which topic you want to write your project about, or your paper about, and you start a process of finding literature, finding information. So you will have a list of articles that you will read to do so. So this could be like something like that. You don't have, again, you don't have to read the whole paper that you find. You don't have to explain the whole thing. Just read the abstract, read the introduction, describe briefly the objective of the paper, and also with one of two that you find is completely enough. Of course, if you want to give me 50, okay, but one or two, it's more than enough. Also, you have to elaborate a bibliography. This is important. Cite everything that you use for the papers, cite them appropriately. Just look for bibliography guidelines or something. I really don't like to see a badly made bibliography. So if I found that your reference page is wrong, I will send it back. Okay, so yes, please write all the bibliography correctly and cite everything you use. So you submit your essay in a PDF format. I don't want to see any Word documents, please, to my email. The assignment is individual, and the deadline is 3 weeks from now. So on the 25th of this month, this is the deadline. If you send me the assignment before this deadline, I'm maybe I will have time to read it and to give you some indications. So the sooner you send it to me, the more time you have to correct things if I think it's necessary. And also, I will be giving you the guidelines for the homework to hopefully next week. So the sooner you make it, you won't have to deal with 2 assignments or more if you have another class or something. So the deadline, you have 3 weeks. So you have to send it before the class in week 8. And it will be great with Hugh, 3, 4, or 5. Okay. Vale. Oh, okay. So how we know if the sensitivity effect is peer reviewed? Well, usually, if it's in a publication, like in a index, I'm sorry, I just forgot the word. Give me a minute.
Journal, maybe.
Journal, yes, journals. Thank you. If it's in an index journal, it's usually peer reviewed. But as I said, you can submit an article. Most of the scientific papers that you find are going to be peer reviewed. But if you want to know if it has been peer reviewed or not, just find the journal information and they will tell it to you. And then, what do you mean with elaborate by bibliography? I want you to do something like this. Something like this. Just say a list with all the information that you use. Just not
like a reference list.
Sorry?
Like a list of references.
Yeah, that's and do it correctly. I just put the authors, the title, the year, the edition, all of that. If a very useful tool for elaborating bibliographies and elaborating reference lists is Google Scholar. So Google Scholar has a very nice, all the databases and for scientific papers and scientific contribution have this has something similar, but Google Scholar is very
should we use Oxford or Harvard, or does
Yeah.
it not matter?
I don't mind about that. Just use whatever you find more comfortable, the one that you find prettier. Just be consistent. What I don't want to see is a wacky bibliography. Okay, I don't like that. So, for example, let me share with you my screen. Okay, I'm sorry, it's in Spanish, but you know. So, for example, I'm clicking on this publication. No, maybe not this one. So let's find a publication. So let's see. I want to talk about capacity. This one, capacity planning space, for example. Okay, and I find this one and I read it and I say, okay, this I'm going to include this in my paper, in my essay. So if you click on this little, you will have all the bibliography already set for you. So just copy and paste. Okay. So this is a very nice tool, and all the pages for journals have this kind of resources for citations. So use something like this.
Must we use Google Scholar, or can we use like Linköpings Universitet has its own library where you can find on the web like articles and reports and stuff like that?
Yeah, you can use whatever. Actually, it would be better for you if you would use the Linkoping database, because you will have access to papers that may require subscriptions. So use whatever is more you are more comfortable with. So yeah, you can use the Linkoping University library, or whatever you find better.
Okay.
But yeah, as I said, you have to find one of two papers. So even though those papers that are not fully available, like you require some kind of subscription, they will have the abstract available for you. So even though you find it and you cannot read it, if it's relevant to the topic, you can include it as well. But don't worry. This doesn't mean that you have to do a proper literature review or anything. So don't worry too much about that. You will have to read scientific papers later in the class for assignments 2 and the class project. So in here, I just want you to find it. I want you to do a little digging in the library and digging on whatever internet search engine you like, and just find some relevant information about the topic.
Do you post this slide regarding the homework on the web page later so that we can access that?
Yeah, of course I will. I haven't done it yet, but I will try to do it today.
Okay.
Okay. Perfect. Again, if you have any questions about the homework or about anything else, just write me an email, and I will do my best to help you. Okay, so let's go because it's 15 minutes from now. So sorry, you were saying?
One last question. So the content in the scientific papers, that should be related to the solution that we have chosen.
Yes, it should be.
Okay.
So for example, you decide to talk about remote towers, for example. You say, so remote towers are this solution, it's tackling this problem and this other problem. It will bring this kind of benefits. And for example, these authors talk about this in this paper. and these other authors talk about this solution in this other project. Something like that. Just don't, it must be related to the topic that you choose. It must show that some research and development has been already done regarding that solution or that topic. And that's it. Okay. See you next week then.
Bye.
Okay, bye.
Bye.